Hi, I'm Zor. Welcome to Unizor Education. Continuing topics related to permutation. Today I would like to talk about permutations with repetition. Now let me explain what it is. In the previous lecture, when I was talking about permutations, I was actually discussing the idea of having certain number of objects put into some order. And now the number of the variations of how we can put all these objects into a certain order was basically n factorial, where n is the number of objects. Now why? Because we have to choose which object is number one, and we have n possibilities. Then after this is done, this step number one is done, we have remaining n minus 1 objects in our set. Excuse me. And so for the candidate for number 2, we have n minus 1 choices. So we have to multiply by n minus 1 if we would like to know how many different pairs we have. Now we continue this process, and every step we diminish the number of choices because something is already taken from the pile. So it goes all the way to 1, and that's what makes n factorial. Now, the permutations with repetition basically means that we are not really physically extracting the object from the pile and put as object number 1 and then object number 2, etc. We are copying this. Now, the example can be something like this. You have only two letters, A and B, and you would like to construct words of the length 3 letters, choosing these letters. So I'm not really like taking out the object, I'm just using. So I'm copying from here or from here to the place number 1, and there are basically in this case two choices, right? A or B. Then I pick for the letter number 2 again from the same set, A or B, and it's also two choices. And then again for the number 3 spot I will have again two choices, A or B. So every time I have exactly the same number of choices. The number of choices is not diminishing as in the regular permutations case, when I'm extracting from the pile and put as this is number 1, this is number 2, etc., diminishing the pile. Now here I'm not diminishing anything, I'm just using these A and B. So the number of choices remains exactly the same. Now, instead of, therefore, multiplying these number of choices, diminishing number of choices, in case of repetition, we are multiplying the same number again and again and again. So, the point is that in this particular case, it's n to the power of n. Now, if we would like to choose not exactly the same number of objects to use, like in this case we have only two objects, but the number of the length of the words which I am making is 3. So this is not necessarily to have exactly the same number. I can have any number, since I am using with the copying basically methodology. I can have any number of objects from this set in a group. Now I can have, let's say, the group of the lengths k. In this case, k is equal to 3. Well, whatever the length of the group is, for every member I have exactly the same number of choices, and if the length of the group is k, so it's n to the power of k. Now in this particular case, now the number of letters in every word is 3, so I have two choices for the first letter, and for each of them I have two choices, the same two choices for the second letter in the word, and for every pair, I have exactly 2 choices for the third. So it's 2 times 2 times 2, which is 2 to the third degree. So n in this case is equal to 2. That's how many objects we have in our initial set. And k is basically the length of the group we are putting together using these particular objects. So that's the formula. This is a generalized formula which obviously should be proven, and the obvious methodology is to prove it by induction. I'm not going to do it right now. I would rather leave it to you as an exercise. And the logic is exactly the same as the logic which I was using to prove the formula for regular permutations, the n factorial, in the previous lecture. The only difference is that the number of elements in the initial set is not diminishing as steps are covered one after another. It's the same n and n and n. And we have to make actually any number of steps depending on what's the size of the group we want. So induction by, let's say, by k. In this particular case, what if the length of the group is 1, for instance? Then obviously we have n choices. What if it's the group length is k? Then we have this, we assume it. Well, I'm not going to talk about it. This is your exercise, all right? Now, instead, what I will do is I will have a couple of examples. I have 4 examples here, practical examples, real problems, where permutations with repetitions are used. So here they are. Now, first one, let's consider you have 6 questions on the exam. Now, each question can be either yes or no. So, basically, you have your 6 answers, yes or no, whatever, and one particular result of the exam, which is the answer to all these questions, represents one particular permutation with repetition. Repetition because obviously yes and no can be repeated as many times. So this is yes and no, this is our initial set of choices, and we have to make 6 choices. So instead of using the formula, which I hate, I use the formula very, very rarely because I have to remember it, etc. I'll just use the logic. Well, let's just consider. Now, I'm facing the question number 1. I have 2 choices, yes or no, right? So I have already 2 different variations. Now, with each of these, I'm going to the question number 2, and I'm also presented with only 2 different choices, yes or no. So, for a couple of questions, I have so many variations, 2 times 2, because with each of answers to the first question, I have 2 questions, I have 2 answers to the second question. And with each of these 4 answers to my first 2 questions, I have 2 different versions of the third question, and to the 4th, and to the 5th, and to the 6th. So that's the result. And obviously I have 2 to the 6th degree, which is 64. That's the answer. So I have 64 different combinations of the answers to exams. Now, what actually can be done, let's say, if you would like to computerize checking of these things? Well, you can have, for instance, you can consider converting all these 64 different variations into, well, 64 different numbers, if you want. Basically, it means that, well, let's say the answer no would be 0, and then answer yes would be 1, and then and then you can use this type of a technique, and you can construct 64 different numbers, and there is only one number which is correct. So as soon as your preparation converging the whole answer into one of the 64 different numbers is done. So the answer, the sheet with answers yes or no, is converted into one number from 1 to 64. All you have to do then and compare this with one particular number which represents 6 correct answers. Let's say it's 37, whatever the number is. So if the answer is equal to 37, it's the exam is passed. If not, it's failed. Basically, that's it. Well, considering that any wrong answer constitutes the failure of the entire exam. I like that. Anyway, next question. Next problem, rather. Okay. You have 3 different dishes, and I can offer you beef stew, chicken parmesan, and grilled salmon. 3 different dishes. So you have 3 choices. You have beef stew, you have chicken parmesan, and grilled salmon. And what you have to do is you have to pick one particular dish, and you do it within a week, 7 days in a row. All right? So for 7 days in a row, each day you're picking either this or this or this. And it's fine, you can have 2 beefs in 2 different days, that's okay. It's permutations with repetition. So what's the available choices are? Well, for instance, B, B, and B, and B, and B, and B. So every time, 7 B's in a row, 7 days you're eating beef stew. Yeah, that's a choice. Or B, C, 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 whatever. 1 B and then 6 C's. That's another choice. So how many choices altogether? How many different variations of a week of meals you can have? Well, again, let's think about combinatorically. For the first day, you have 3 choices. Now, with each of these, you have 3 choices for the second day, because we are talking about permutations with repetition, right? So again, the number is 3. Now, for the third day, you have exactly the same 3 choices. So for each of these, you have, again, 3 new ones. And 3, and 3, and 3, and 3. 1, 2, 3, 4, 5, 6, 7. 7 days in a row. Each day you have a choice of 3 dishes. So it's 3 to the 7th degree. You calculate it yourself what it is. Next, I am a New Yorker, and I love to go to performances, and I have 4 different things which I like. I like cinematography, I like jazz, I like musicals, and I like drama. So that's my choices. Now, I'm not very rich, so I can go to the performance like this only, let's say, once in a quarter. So it's 4 times a year. So 4 times a year I go to one of these performances. So what's the total number of different combinations of different performances I can view in a year? Well, I can have 4 times I go to cinematography. Or I can have 2 musicals and 2 jazzes, for instance. I mean, whatever the combinations are. Question is how many are all together. Well, considering that the order is important here. So that's what for instance, if I go in the first quarter, I go to the movie, and the second quarter I go to the movie, and then I have, let's say, 2 drama performances, that's not the same if I do it in the reverse order. So the order is important. So for the first quarter, I have 4 different choices. With each of them, I have 4 different choices for the second quarter, and for the third, and for the fourth. So 4 times I'm going to one of these 4 shows, so I have 4 to the 4th degree. That's my answer. Now, finally, I have to construct 3 digits I'm using as a number. Now, how many different 3-digit numbers exist? Well, from pure arithmetic, we know that 3-digit numbers are from 0 to 999, right? So, how many of them? 900, right? So, I have 900 different 3-digit numbers. Now, how can I get the same number using the combinatorics? Well, let's just think about it. If I have a 3-digit number, what are my choices for the first digit? Now, remember that the first digit cannot be 0, so it can be 1, 2, 3, etc. So for the first digit, I have 9 choices. Now, with each of them, I have 10 choices from 0 to 9 for the second digit, right? So with each of these, I have 10 of these. And the same for the third digits. For the third digit. So, and this is 900. So, this is a little twist, because it's not the same number of choices on the same step. Now before, all these problems before, we had exactly the same set of initial elements, initial objects, and we choose from the same set, again and again and again. In this case, because of the peculiarity of our numerical system, we are saying that the first step is a choice of only 9 digits out of 10, because 3-digit number cannot start with 0, right? So that's why this number is slightly changing. This is a little twist in this program, in this particular task. Well, that's it. I would recommend you to read the notes to this lecture on unizor.com. Well, if you are using signed-on procedures and you have your supervisor who can basically enroll you in some course, well, that actually makes the whole thing much more practical, and the whole educational process will be much more beneficial for you. So thanks very much and good luck.